Hello and welcome. Today we are using our similarity properties in order to estimate how big the sun is. We are using similarity and scale, that scale factor, to estimate the size of our friendly fireball. Knowing, of course, that by looking at that friendly fireball up here, it's actually not so friendly as a thing. In fact, remember that our sun is this huge nuclear reactor out in space. It puts off an incredible amount of energy. It helps us energize every single piece of life on Earth, starting from photosynthesis all the way up to us. And today we're going to use that friendly fireball and we're going to try to see how big it is across. So try to find the diameter of this whole beast right over here, this lovely thing. So remember that we are far way away from the sun. So I know that it looks very small for us, maybe about the size of a nickel, you could cover it up. But remember that from over here, Washington, we're approximately 93 times 10 to the 6 miles away from the sun. It's a really hard number for me to understand. So the way I try to kind of wrap my head around this, I don't really have a concept of a million. I know it's a big number. So I think about, hey, if you were to walk down the street, wherever you are right now, just walk for 20 minutes. You've then gone about 1 mile. So after 20 minutes of walking, you've gone 1 mile. Imagine doing that 93 times. Already I'm like, that's a lot of walking. Wow, that's a big thing. So that would take many days to do without even stopping. And then think about that, and then times 10 to the 6 means you're doing it 1,000,000 more times. Wow, we are far away from our friendly fireball, the sun. So in order to, let's, refresh our minds. In order to estimate how big the sun is, I want us to think back to 2017, so long ago, and you might recognize this picture. This is the solar eclipse that happened at that time. So big flashback right now. Remember we had that solar eclipse, and from the Seattle Times, you might remember seeing this. Oh my goodness, there was a solar eclipse that was happening. Remember all those things that maybe your science teacher told you how to make a pinhole projector because you don't look at the sun directly, unlike some of our world leaders. So we really wanted to make sure that you were not going to stare into the sun and burn your retinas, part of your eye back here. And you might have used something like this. This is someone who used a colander. You might have been really cool and just used your fist and just made a tiny hole, and you can see that eclipse, there's the moon blocking part of the sun right there. So seeing images of the sun through a shadow or through a small slit is not very new to us. And of course, this comes to my favorite image from the solar eclipse. If you ever looked at the tree shadows, you saw tons of these images as it was filtered through the trees, and little images of the sun popped up everywhere. I'll get rid of this one. And then, of course, you can see the moon blocking it everywhere. But that same thing happens. You don't have to wait for an eclipse to see cool images like this. Here's one that comes to me almost every day that it's sunny out. This is on my bedroom wall. And you have these line of images right here that are all images of the sun. This is actually a picture of the sun. So you can actually see, I'm going to show you what this looks like. So these are the sun images. Let's play this video. Can we do that? Uh-oh, come on. There we go. So notice that I have those kind of slits coming through on my window. And then through the blinds, now you can see, hey, as my hand travels up and down, it's actually blocking out each of those discrete images of the sun, each of those circles as we go through. So I took a closer look at one of these, and here I am, I'm measuring the width of the sun. So I took a look at this all the way across, found out what that measurement was. So I wanted to see, well, how big is the sun actually appearing when it shows up on my bedroom wall? Turned out to be 1 3/4 inches. If you're curious about how I made that measurement, I basically just lined that ruler up and then I twisted it around. I rotated it up and down until I saw that I got the biggest measurement really carefully. And that was my 1 3/4 inch measurement there. So I'm going to use that. We're going to go over to our workspace real quick. So let me get out of this one. No, we can discard these ink notations. Here's our workspace. So here's what happened. I put down that 1 3/4 inches you can see right over here. I'm gonna move my picture over there. And then I also measured, I really wanted to measure, okay, well, what's the distance between my wall and my window over here where my blinds were, where they were filtering out the sun on the side. And I measured that and it was 136 inches. So now I have this nice little triangle. Hopefully you can see this nice triangle over here. I'll highlight it in, ooh, actually let's highlight in green real quick. So there's my nice triangle. You can see it popping out here. And really what I just did is I found a triangle that is going to be similar, similar to the one between my window and the actual sun itself. Wow, I can't really get rid of that highlighter, can I? One more try. Come on. You know you don't want to be there anymore. You know this. Aha, there we go. All right, so remember that the sun, here we go, here's my similar triangle. So imagine I take my triangle that I just highlighted in green before, and I'm going to rotate it around. So I flip it basically 180, and then I dilate it. So I make it much, much larger until instead of 136 inches long, it is 93 times 10 to the 6 miles long. Unit change. Whoa. And then, likewise, then we'd have, instead of 1 3/8 inches, we'd have this dilated side over here, which is going to be the diameter of our sun. And that's what we're going to try to find. But in order to find that, we need to understand, so what is the scale that we just did? How many times did we blow this up? What is our dilation factor? So in order to do that, we're going to compare our image to our pre-image right over here. So I set up our scale factor ratio. So I know it's 93 times 10 to the 6 miles, and that's compared to 136 inches. As I warned before, those are different units. So I'm going to do a little bit of conversion on the side here. Side math. So I know that it's 136 inches per every 12 inches. We have 1 foot. And we need 5,280 feet to make 1 mile. So my inches will cancel up, down. This will cancel. I'm left with my miles. I'm going to bring out my handy-dandy calculator right over here. There's no need to do this math in my head. We could, but I'm not going to force you to. There we go. So we get 0.00, slide over, 2, 1, 4, 6, approximately 5 miles. So that's how many miles we are. So I'm going to replace this guy. Instead of putting in the inches, and I'm not going to compare two different units together. That's comparing apples and oranges. No sense in doing this. There we go. So now let's go ahead and let's find this. So all I'm doing is I'm putting this into my calculator again. 93 times 10 to the 6th power divided by that small little number, which is the length of my bedroom from that window to where that image appeared on my wall. And that gives us, actually, I'm going to put this in green, labeled as my scale factor, 4.33 approximately times 10 to the 10th. That's my scale factor. There's actually no units on it, but that's how many times up I scaled it. So before we were looking at like multiply this triangle by 2. Well, now try multiplying that triangle by 4.33 times 10 to the 10th. So let's go ahead and do it. Let's find out what that diameter is. So again, I know that this little piece over here is 1 3/8 of an inch. I want to find out how big the diameter is over here. So I'm going to take my 1 3/8 of an inch and I'm going to dilate it with this scale factor. So I'm going to plug this guy right in here. Again, going back to handy dandy calculator, multiply by 1 3/8 of an inch. Check my math on your own calculator, please. That gets me to, let's get blue, 5.96 times 10 to the 10th inches. Not very useful when it's in inches. This is just a really big number. Let's convert it back real quick. So now I know I can take my inches, just like I did before. There are 12 inches per foot. That's my nice little ratio there. Another ratio is 5,280 feet per mile. Don't ask how I memorized that number, by using it a lot. Inches cancel, feet cancel. I'm left with just miles. So now we're going to take this big honky number, divide it by 12, divide it again by 5,280. This is now how many miles across. Ooh, estimate it to 2 miles. So, oh my goodness, it's about 940,000 miles across. Whew! That's a long way across. So let's go back and let's see if we can continue from here. So we just went from our workspace. We're going to ignore that little guy. So now by looking at this, we saw that actually this distance is about 940,000 miles. And that's from our little place in Washington over here all the way over here. We saw that was actually 9 point, or 93 times 10 to the 6, or 93 million miles. Wow, these are big distances, but we can figure it out using similar triangles. So our final diameter that we found right here, as we said, I'm going to put it down in red because you can barely read it. I'm going to put it down the side so maybe we can read a little bit better. 940,000 miles. Again, imagine walking for 20 minutes, doing that 94 times, doing that another 10,000 times. Whew, it's a lot of work. So thank you for watching. That's how we can estimate the size of the sun. Here's a little video.